Hey guys, welcome to 2.1. We're going to be talking about basics of functions and their graphs. All right. First thing you need to know is this concept of a relation. A relation is a set, any set of ordered pairs. All right. So like any ordered pairs, that's a relation by default. All right. Now, if it falls under a certain criteria, then we can say it's a function. All right. So the set of all independent variables or all your x's. So if your ordered pair is x comma y, then all your x's are your domain, all your y's are your range. And that's going to be a big part of our conversation today. And then a function is a relation where none of your x's repeat. Okay, so for number one here, first of all, we're trying to figure out, is this a function, is it not a function? And then we're going to make a list of the domain and range. All right, you see if it's a function, check all your x's. Does any of them repeat? I got 2, I got 6, I got 7, none of them repeat. So yes, this is a function. Okay, and then my domain is again all my x's, 2, 6, 7. And for this one, my range is the same as my domain, 2, 6, 7. So there are some repetitions, but the x's don't repeat, the y's don't repeat. Okay, so there's 2, 2, but one's x, one's y. There's 6, 6, one's x, one's y, so forth, so on and so forth. That's not what we're talking about. Do I have any x's that repeat? Do I have any y's that repeat? All right. If y's repeat, that's a conversation for another day. Right now, we're just concerned about the x's. On number 2, we have 5, 9, 5, 10, 5, 11. All right, because every x is a 5, that means they repeat, which means this is not a function. In my domain, it's just simply going to be 5. My range is all of my y's. So 9, 10, 11. So in this conversation about functions, you want to know is just by looking. Obviously, we can tell by the graph, which we'll look at in just a second. We can tell if a graph is a function or not. But we can also do it by looking at the equation. And you want to know if the x and the y have a power of 1. If they have any other powers, then it's not going to work out. So is this a function of x? Well, all you have to do is number 1, or sorry, number 3, x has a power of 1, y has a power of 1. So you can go ahead and say yes. If you don't know, still don't know, you can solve for y, and then y would be negative x plus 1. Right, that's your equation of the line. And so you know exactly that a line is a function of x. So this works out. So this is a yes, it is a function of x. Number 4, sometimes they just want you to solve it and tell you what the solution is. So like number 4, I'm going to work all this out. So it's going to be 5x minus 10 plus 19 equals 4x plus 16. Okay, so let's clean this up. It's going to be 5x plus 9 equals 4x plus 16. I'm going to move the 4x to the left. So it's going to be x plus 9 equals 16. X equals 7. Okay. Now, on number 5, when you see in this conversation about functions, when you see f of x, this thing right here, when you see f of x or you see g of x or anything like that, this is what we call function notation. All right. And it's the same thing as saying y equals 3x plus 1. All right. Y equals f of x. Now, it's written like this because, as you can see, we're going to find f of 7, f of x plus 3, and f of negative x. So f of 7, this is going to be 3 times 7 plus 1. All right. 3 times 7 is 21, plus 1 is 22. Okay. So there's that. That's the first one. You have 3 times x plus 3 plus 1. It's going to be 3x plus 9 plus 1. So that's 3x plus 10. Okay. And then here, I got negative x. It's going to be 3 times negative x plus 1. This is going to be negative 3x plus 1. That's all there is to it. Okay. So all you're doing is what f of x is your basic, it's your default. All right. And then anything that you see in parentheses where x should be, you plug it in for x. So on the first one, it says f of 7. So anywhere I see an x, I'm going to plug in a 7. The second one, anywhere I see an x plus an x, I'm going to plug in an x plus 3. And same thing for the last one. So that's what you do. Number 6, this is talking about transformations. So simply, but transformations, you can move the graph, the original graph, up, down, left, right. You can stretch it. You can shrink it. You can do all these things. And so what you want to do is you want to know, is it going up and down? Is it going left and right? What is it doing? Well, the first one is just simply the absolute value of x. And the second one, g of x, is x absolute value of x plus 8. Well, let me give you a quick rundown here. If this was x plus 8 inside, that would be it. This would then be a horizontal movement. As it says here, this is a vertical movement. Okay, so that's under take consideration. Is it inside the function or outside the function? In this case, 8 is outside the function. So this is going to be shifted 8 units up, or up 8 units. Okay, pretty basic. So let me do a quick rundown. Whether it's a parabola or absolute value or anything like that, this is what your graphing form looks like. It's x minus h plus k. H is your horizontal movement. K is your vertical movement. All right. It says plus K. So while I go in our number 6, it says plus 8. So that tells me I'm doing up 8. Or if it was minus 8, it would be down 8. Inside it says minus H. So it's the opposite of what you think. Minus H, if that was minus 8 on the inside, that would be right 8. And if it was plus 8 on the inside, it would be left 8. Because of that minus sign, it changes everything, makes it the opposite. And then the A out front, it does 2 things. If it's negative, it means it's opening down. If it's positive, it's opening up. If it's greater than 1, it stretches. And if it's less than 1, but greater than 0, so like a fraction or a decimal, that means it shrinks. So that's what we consider. On number 7, I mentioned a while ago, you can see if something is a function either by the equation or by the graph. And on 7 and 8, we're looking at the graph. And to check the graph to see if it's a function, we perform the vertical line test. And what you want to know is 1 or 2 things. So I'm going to use this ruler. Do I ever hit a gap? That's a no. And I don't ever hit 2 x's at the same time. So this is a function. Over here, do I hit a gap? No. But do I hit 2 x's at the same time? I do. Does my pencil or my ruler hit 2 things at the same time? It does. So this is not a function. Okay. Now, oftentimes when it comes to functions, they'll give you a graph and they'll say, okay, at f of whatever, what is this graph? So this one says f of 3. So you want to know when x is 3, what is the graph doing? So I got 1, 2, 3, and my graph is right here. So at f of 3, y is 2. Okay, so that's how you do it. Here's 3. That's what it's doing. That's essentially what you're doing. Okay. Number 10, right? Pay attention to this one. So I'm going to take 2 and plug it into G. So I've got negative 5 times 2 plus 8. That's going to be negative 10 plus 8, negative 2. Okay, and then the next one says f of G of 2. So I've already done G of 2. So what I'm going to do is I'm going to plug I'm going to plug negative 2 in there. And now let's solve. I'm going to plug negative 2 into f. So it's going to be negative 2 all squared minus negative 2 minus 9, negative 2 squared. All right, everything is good. This is going to be 4 plus 2 minus 9, 6 minus 9. And that's going to be negative 3. Okay? And that's how it's done there. All right, last one. Once again, sometimes you're not plugging in a number at all. You want to find what f of negative x is and then subtract it from the original. So let's find out what f of negative x is. All right, that's going to be negative x parentheses cubed minus negative x plus 1. Okay, let's clean this up. Because that's not power, that's going to be a negative x cubed plus x plus 1. Okay, so I'm going to take this and I'm going to subtract my original. So I got negative x cubed plus x plus 1 minus, and I'm going to open up parentheses because when you subtract, you're going to have to distribute that negative. So this is going to be x cubed minus x plus 1. Let's distribute that negative plus x plus 1 minus x cubed plus x minus 1. Okay, so the minus 1s are going to fall, plus 1 minus 1 is going to fall out. I'm going to have negative 2x cubed plus 2x. And that's it. So I hope you find that chapter 2 is super basic and the conversation is just getting started. So if you have any questions, let me know, and I'll see you in the next video.